Hi guys, next lesson here, and in this one a very important lesson, okay? So we're going to learn how to go writing from either exponential form to logarithmic form or the other direction, log form to exponential form, okay? So really important lesson in terms of understanding how to go back and forth between the two different ways of expressing functions. So just bear with me, okay? Take it slow when you're doing the homework. And I'll give you a couple of days to work on this to make sure that we understand it, because we'll need to know how to do this moving forward, okay? Really important. So it just says in the last unit we introduced log functions as the inverse of an exponential function. So again, you probably want to highlight that, okay, that we have log functions, okay, which are the inverses, okay, of exponential functions. So for example, when I have an exponential function y is equal to 2 to the exponent of x, the inverse of that is either this, okay, x equaling 2 to the exponent of y. Remember, we just interchanged the x's and the y's. Or this can also be written like this: y is equal to log base 2 of x. So the x equaling 2 to the exponent of y and the y equaling log base 2 of x, those are the same. So again, just some definitions as we kind of start this lesson. An exponential function, okay, is going to be written in this form: a b to the exponent of x. And a log function is y is equal to log base b of x. And when we talk about b in a log expression or a function, that b is called our base. So some things we've taken a look at already. When I talk about a logarithm, okay, the argument, okay, which they've bolded here, so obviously an important term, is this value right here, okay, that's the x, okay? And again, the important thing is that that argument can never be negative, and the b value inside here, that's our base, okay? And this is the value of the log. So again, all those terms are going to come up as we discuss moving from exponential to log forms. So again, if you need to refer back to those definitions, okay, maybe not a bad idea. Now, common logarithms, okay? Common logarithms are logarithms that are base 10. So I would highlight common logarithms, okay, and base 10. So what that means is if when you look at a logarithm, you don't see a base written, the base is 10. So for example, in the example here, they say I have log base 10 of x. It's often written as just a log of x, okay? See how there's no base there? Okay, so when it's base 10, they will not write the base, okay? And note that log right here, okay? That log of x and y equaling 10 to the x are, again, inverse functions, okay? That's because in that first log expressions, there is a base of 10 right there that they do not write, okay? The next thing we have to discuss before we move on to try some questions is what we call natural logarithms, which is the ln, log natural key. Okay, you can find both the log button and the natural log button on your calculator just to the side of the number 7 and the number 4. So if you look there now, you'll see log beside the number 7 and ln beside the number 4. Now, not natural logarithms, ln, okay, are logarithms where the base is e, and we studied the value of e in the previous chapter. So again, instead of writing log base e of x, they will write natural log of x, okay? Those are going to be important, again, also moving forward here. And again, note that the natural log of x and e to the exponent of x are inverse functions, okay? Inverse functions are reflected in the line y is equal to x, and that's what we're going to kind of take a look at now on the next page. So if you do turn to the next page, it does say we're going to investigate log and exponential form. So they've given us tables of values here for both 2 to the exponent of x, okay, which they've labeled, and you can see on the graph as this graph here. And then they've also labeled log base 2 of x, okay, which is the inverse, okay, and that graph is right here. And again, those graphs are always reflected in the line, okay, y is equal to x, okay, so that is our graph and our reflection line right there. Okay, so there's the line y is equal to x. Okay, so we created these graphs in the last chapter. We inputted the x's and got the y's, and again you can see that if I interchange the x's and the y's, okay, I get the other graph. So here the x's become the y's, like so, okay, and the y's become the x's, okay. So that means that the domain and ranges are also interchanged. Okay, again, just a past note from last lessons. Now, it says the tables show that the coordinates of the points on y equaling 2 to the x and y equaling log base 2 of x. Notice that the point 3, 8, so this is an x value, this is a y. On the graph of y equaling 2 to the x indicates that, so there's that y value, okay, and here is the x value. I'm just inputting the x and y coordinates into the equation. Then they switch the x's and the y's. So this is now the x, and this is the y, which means I'm going to discuss the inverse function, log base 2 of x, and again, there's the y, okay, and log base 2 of x, so the x value this time was 8, okay? So they're going to ask me to do a very similar thing here. It says, what can we make about the point -2, 1 over 4 on the graph y equals 2 to the x? Well, this is an x value, and this is a y. So simply I go into the equation, and for y I go 1 over 4. And for the value of x, I'm going to put in -2. So you can state that 1 over 4 is equal to 2 to the exponent of -2. Okay? And then a very similar idea in the next question. This is an x, and this is a y. So I go into my equation, and for y, I put in 4. Okay? And that means it's going to be equal to log base 2 of 16. Okay, I just substituted the x and y values into the expressions and the equations, and I'm good. So now, what I really kind of want to get to here is how to go back and forth between exponential and log forms. So in the first question here, okay, I have log base 2 of 8 is equal to 3. Now in exponential form, that's the same as saying 8 is equal to 2 cubed. So here's what happens. This number here, which is our argument, 8 is equal to 2 to the exponent of 3. And that's how they get this expression in log or exponential form, which is right here, okay? So again, 8 was equal to 2 to the exponent of 3. Now, if I use that same basic logic, moving on to the next question, okay, I'll start here. Log base 2 of 4 is going to equal, and I know it's going to be 2. How do I know that? Because 2 to the exponent of 2 is equal to 4. Okay, so that's all that I do over here. I say 4 is equal to 2 to the exponent of 2. Okay, next one right here. Log base 2 of 2 is going to equal 1. Okay, how do I know that? Because 2 to the exponent of 1 equals 2. So that's all that I write here. 2 to the exponent of 1 is equal to 2. So 2 is equal to 2 to the exponent of 1. And the last one, okay, log base 2 of 1 will equal 0, okay, because 2 to the exponent of 0 is equal to 1. Okay, so 1 is equal to 2 to the exponent of 0. Okay, now in the second part of the table, they're going to have us go the other way. They give me the exponential form. 2 to the exponent of 3 is 1 over 8, so that means 2 to the exponent of -3 will equal 1 over 8. And there you go, you're done. Moving on to the next one, 2 to the -2 equals 1 over 4. So that means when I write it out, it's going to be log base what? 2. Okay. It'll give me 1 over 4, and that means I have to raise 2 to the exponent of -2 to get the 1 over 4. Okay. And in the last one, this is going to be log base 2 of 1/2 equals -1, because 2 to the exponent of, -1 equals 1/2. Okay, so that's how we're going to go back and forth between exponential and log form. And again, don't worry, I'm not just going to leave you high and dry with that. We're going to use that quite a bit here moving forward, and you'll see that they have us calculate both exponential and log values, converting back and forth a whole lot here in the next little bit. So on the next page, it says, use the patterns developed from class example 1 to write the following exponential statements in log form. So this is exponential form. Okay, 10 cubed equals 1,000. In log form, it would look like this. Log base 10 of 1,000 equals 3. There it is in log form, because 10 to the exponent of 3 equals 1,000. Okay, using that same logic on the next page, it's going to be log base 3 of 81 is equal to 4. 3 to the exponent of 4 equals 81. Okay. In B now, they have us go the other way. It says use the patterns to write the following logs in exponential forms. So it's going to be 5 to the exponent of 4. 5 to the exponent of 4 is equal to 625. Okay. In the next one, a little trickier because this is a common logarithm. Remember, when you don't see a base, the base is 10. So this will be 10 to the exponent of 2 equals 100. So don't be afraid to always write that base of 10 in there if you don't see it. It really helps when you're converting, okay, from form to form. So just some general kind of things here that we want to take a look at, okay, and make sure that we remember, okay, are these 2 points right there, okay, showing you how to go from log to exponential and how to go from exponential to log form, okay. So let's practice those on the next couple pages here. So again, convert each of the following from log form to exponential. Okay, so this one is going to be 7 to the exponent of 4 equals x. So 7 to the exponent of 4 is equal to x. Okay. In the next one again, you'll notice that you don't see a base. Okay, so that means the base is 10. So it's going to be 10 to the exponent of 4 is equal to x. So again, if you want to write that 10 in there, okay, probably not a bad idea. Okay, in the next one, it's going to be 5 to the exponent of y. So 5 to the exponent of y will equal 15. And then the last one, okay, so just a generic kind of question here where they don't have any values, all variables. It's going to be t to the exponent of m. So t to the exponent of m is equal to b. Okay, and there you go. All right, next set of questions, again, going the other way. They want you to go from exponential to log form. So this would have to be log base 4 of 64 equals 3. Okay, and I know that because 4 to the exponent of 3 has to be 64. Okay, in the next one, it's going to be log base 2 of 1 over 8 is equal to negative 3. And in the last one, okay, again, log base e of f will equal d. Okay, again, just lots of practice with this. And again, any questions, feel free to email me and I'll get back to you with some help. Now that we've practiced using expressions to go from exponent to log form and log to exponential form, just like last day's lesson, we are now going to use that to solve equations, okay? So again, though, now you'll see an equal sign, and at the end of the question, we want there to be a value for whatever variable it is we're solving. So it says, in each case, express the log equation as an exponential and then solve for the variable. So if I convert the first one in a to exponential, it's going to be 6 to the exponent of 4 equals x. And then all you have to do in your calculator is figure out what 6 to the exponent of 4 is, and that will be 1,296. Okay, and there's your value for x. Okay, in b, same kind of idea. I'm going to have b to the exponent of 2 will equal 144. Okay, I obviously want b, so I have to take the square root of both sides of the equation. And in this case, b therefore will equal 12. In c, it's going to be b to the exponent of 3 over 2. So b to the exponent of 3 over 2 equals 125. Now we use our knowledge from last day. Okay, I want to have just b. So if it's to the exponent of 3 over 2, I have to raise it to the exponent of 2 over 3. And so I have to do that to both sides, raise both sides to 2 over 3. I'll be left with b on the left-hand side. This means I'm going to take the cube root of 125, okay, and then square it. So the cube root of 125 is 5, and 5 squared is 25. Okay, and then the last one, you're going to have 36 to the exponent of y. So 36 to the exponent of y is equal to 6. Okay, now we use our basic idea of creating powers with the same base. So this 36 here, I'm going to write as 6 squared to the exponent of y equals 6. And remember, 6 is to the exponent of 1. So this will be 6 to the exponent of 2y equals 6 to the exponent of 1. So therefore, 2y will equal 1. Okay, and y will equal 1 divided by 2, or 1/2. Okay, so again, just using some of the stuff we learned today and what we learned last day, creating powers with the same base. Okay, next. So it says, by converting from log to exponential form, okay, they want me to calculate the value of t. So what happens is that they give me two expressions here, okay, 1 and 2. The t I'm looking for is right here, but in order to solve for that, I need to use this expression first. So what I'm going to do is I'm going to go 2 to the exponent of 3 is equal to x, right? 2 to the exponent of 3 is equal to x. So we know that 2 cubed is 8. So I now know that x has a value of 8. I take this piece of information into this part of the question now. So now I can say log base 2 of t equals, and instead of x, I can substitute that with 8 because I just solved for that. So now 2 to the exponent of 8 is equal to t, and 2 to the exponent of 8 is 256. So there's my value for t, okay? In B, very similar. Okay, there's the t I'm after, but in order to get to that, I have to use this expression right here, okay? So what I'm going to do is go 5 to the exponent of 2 is equal to x, and we know that that is 25. So I now know that x has a value of 25. Okay, I take this piece of information into this expression and this equation here on the second part of the question. So now I know that I have log base t of, and instead of x, 25 will equal negative 2. So I can say now, turning into exponential form, t to the exponent of negative 2 equals 25. I don't want t to the exponent of negative 2, so I have to raise both sides of the equation to negative 1/2. So 25 to the exponent of negative 1/2. I will have t here, and this will be 1 over 25 to the exponent of 1/2, and we learned that something to the exponent of 1/2 is the same as taking the square root. So this is 5. The square root of 25 is 5, and there is your solution. Okay, just about done. Now, the difference with these questions, okay, compared to the ones that we just did before, sorry, touched a different part of the page there, okay, is that we have an a value here, okay? Now, if we have an a value there, we need to divide both sides of the equation by a first before I can convert it into log form. And that's basically what they're saying right here. If I have this, y equals ab to the exponent of x, I want to divide both sides by a so that it's just b to the exponent of x by itself, okay, on the right-hand side or the left-hand side. So if I take the log form of that, okay, which I'm jumping down to here, the log form of this is going to be log base b of y over a is equal to x, okay? Now we should know that because if I go b to the exponent of x, that will equal y over a, okay? And that's basically what they're saying right there, okay? So let's put that into practice, and you'll see that it's a little more simplistic when I start dealing with numbers, okay? So change each of the following from exponential to log form. So again, you can see here that I actually have y is equal to, and there's your a, and there's your b to the exponent of x. So I want to get rid of that a value. So what I'm going to do first is going to go y divided by 2 equals 3 to the exponent of x. Okay, so there's the first step. Now I can basically turn this into log form by going log base 3, okay, of y over 2, okay, is equal to x. Okay, so there's the first one. In the next one, same thing. There's that a value, so I want to divide both sides by that first. So you're going to go h over 7 is equal to 4 to the exponent of k. Now that I have it like that, now I can write it in log form. So it's going to be log base 4 of h over 7 is equal to k. And the last one, same thing. There's that a value, so divide both sides by that first. So t divided by r is equal to s to the exponent of p. And when I write that in log form, it's going to be log base s of t over r is equal to p. Last set of questions, okay? So going the other way. Change each of the following from log to exponential form, and notice they want it written like this. They want the a and the b both on the right-hand side of the equation. So first thing I do is I write this in exponential form. Sorry, you guys, I keep doing that. Part of my hand keeps touching the top of the page here. So first thing is we're going to go 7 to the exponent of x. So 7 to the exponent of x will equal y over 3. Okay, I want y by itself, so I multiply both sides by 3. So it's going to be 3 times, and then like I said, 7 to the exponent of x is equal to y. And there you go, okay? You can clearly see your A and your B, okay? Next question. So 5 to the exponent of x will equal 7y. And then I want to get rid of that 7 to isolate the y, so I multiply both sides by 1 over 7. Okay, so 1 over 7, 5 to the exponent of x, okay, is equal to y, like so. Okay, and then last question, same basic idea, e to the exponent of x, so e to the exponent of x will equal y over 8, then multiply both sides by 8, so 8 e to the exponent of x is equal to y. Okay, and we're done. So again, practice that. Take a day or two to work through the questions, maybe break it up into sections, do small chunks so that we understand it. Because this is, like I said at the beginning of the lesson, a very, very, very important concept.